Welcome to the first video in this series. In chapter 1, we're going to learn about matter, measurement, and problem solving. So in this introduction, we're going to really think about what is chemistry, how do we think about chemistry, and what do we do with chemistry. So the first thing, in order to really think about chemistry, is we should ask ourselves, what is chemistry? So chemistry is really a study of atoms. And so everything around us is built by atoms. So it's built by atoms that combine together to make things that we're going to call molecules. And so some definitions of chemistry are things along the lines of it's the science that seeks to understand the behavior of atoms and the molecules that make up matter. If everything is combined of atoms and molecules, it means chemistry is really the study of most things. And so another definition would actually be the study of the composition, structure, properties, and the changes of matter. For example, how does something change from one state to another? So we have ice that can be a solid, or water, liquid, or steam, which is a vapor. Chemistry studies how H2O or water changes. What causes that? How can we use that? And sometimes we'll find water in a reaction. So all of this broadly is chemistry. So how do we experience chemistry? For many of you, you're going to watch these videos. But how do we think about that outside of a teaching environment? So, as a chemist, I would argue that it is a huge part of our daily life. So, coffee is the substance of life. So, this morning I brewed coffee, which means that I had roasted coffee beans that were ground. Water was then poured over those in a modified pour over. So, it was a drip coffee today. But the hot water extracts the coffee molecules out of the grounds. So this is a chemical reaction. So polymerization, we find that in water bottles. Some other examples might be fireworks. You could make the argument that many baking components, for example, the baking powder and baking soda used in things like cookies and breads that give a leavening or a rising event, that is chemistry because it's going to use chemical compounds that create vapors or typically CO2 bubbles, and we can see that in the shape of fluffy cookies. So, in addition to our daily life, chemistry really has been important and is essential for the discovery of many items. So, the discovery of electrons, which we're going to hear about in chapter 2, the synthesis of antibiotics and their discovery. In organic chemistry, you'll talk about the synthesis. In biochemistry, we'll talk about how these were discovered, how they're used, and what their role is. Lasers are created from, or you'll study those in depth in physical chemistry, and LEDs and solar panels are involved in inorganic chemistry. So, chemistry is involved in a broad spectrum of our lives. And so, this semester, what we're going to do, or through these videos, we are going to think about how this evolves and is part of our life. So, how do we study chemistry? If you go into a research lab, what are we doing in there? So, if you're in a teaching lab, we're going to give you some experiments. But most chemists and most scientists are curious people. And so it starts with a curiosity, and this curiosity leads to a series of experiments or questions. And so we could have also written the word questions here. And so we either want to prove or disprove a hypothesis. An hypothesis is just a really fancy word for guess. We think it is possible that this could occur. So if we put water below 0 degrees Celsius, we hypothesize that it might freeze. At some point, that might have been a guess. Today, we know that to be true. So through the hypothesis and experiments over time, we're going to reach a conclusion. So if you start with the guess, then we're going to have our experiments and time. And that's going to lead to a conclusion. And so a conclusion is just what we know today. And so it's the summary of the known information. It doesn't mean that there are no additional questions. It doesn't mean that we can't discover more. The conclusion is just the summary of today's experiments. And so this is going to lead to the development of laws and theories. A law is an idealized statement. And an idealized statement basically means we think this could be true. And a theory is a little bit more where there are some exceptions to the rule. So one of the laws that we're going to think about some this semester is the law of the conservation of mass. And this states that in a chemical reaction, matter, which we know to be atoms, molecules, elements, is neither created nor destroyed. And so when we learn about reactions, what we're going to notice is that the elements that are there at the beginning are also present at the end. They're just in a different arrangement. So we're going to rearrange the atoms, but we can't create matter from nothing. And so the theory is slightly different than a law, but together these are the extrapolations or the production of a series of experiments. So this semester, we're going to study chemistry. And chemistry is made up of matter, so we should ask ourselves, what is matter? So a broad general definition of this is actually pretty simple. It is anything that occupies space and has mass. And this is not spelled correctly, so we'll fix that. And so when we think about that, if it's anything that occupies space and has mass, we can start to think about the different states. And so the reality is throughout Gen Chem, we are going to think about things in really three different states. We're going to think about solids, liquids, and gases. So a solid typically is annotated as S. And the states are the physical form. So the atoms in a solid compound are closely packed. And it typically has a rigid shape. So if we think about something that we know to be solid, for example, a water bottle, while it can move if it's flexible, the substance doesn't really change shape. And so whereas the liquid inside the water bottle can be moved around, for example, if you shake the bottle. So in liquid, which is a lowercase, typically script font, annotation, so the atoms are close, but they have a fixed volume, but not shape. So the water inside your water bottle is the same water, whether it's in your whatever type of water bottle you have. So the volume of the water, i.e. the amount of water, doesn't change, but it takes on the contours of your shape or your storage container. So a gas is a script G, and in this case, the atoms are far apart and can be compressed. So we know that a solid can't really be compressed. There is a finite amount of space. Liquids, you can't really make them any smaller. So, but a gas, you can compress them and force the gaseous molecules to be much closer together. So composition here is the basic components that make up matter. And the composition really answers a couple of questions. How are the atoms arranged? And so we can start to think about what the composition is by creating a flowchart. So the composition of matter. This is going to allow us to determine, is it a compound, element? Is it a homogeneous mixture or a heterogeneous mixture? So we're going to make a flowchart. And so the first thing is we're going to ask, is the substance pure? And so we're going to answer that either as a yes or a no. So if the answer is yes, we will go this direction. If the answer is no, we will go this direction. So if the substance is pure, that makes it a pure substance. And from there, we're going to ask a question. Is there more than one element? So that's either yes, and that tells us we have a compound, or no, we have an element. And we'll go back and think about some examples as well as what those are in just a second. So if the substance is pure, that makes it a mixture, or is not pure, sorry. So then we can ask ourselves, is it uniform? So when we think about a mixture, if you were to create something like sweet tea, that would be a mixture. And the sweet tea is quite pure. It's also a mixture if you mix together two cereals, such as Cheerios and Fruit Loops. That's a mixture. But it's not uniform because you could physically separate the two different compounds. So is it uniform? Yes. And that makes it homogeneous. Or no, and that makes it heterogeneous. So if we think about these four or these many different compounds, we can start to think about different parts. So first, we're going to write some definitions for these vocabulary words. Then we're going to come back and think about examples. And so we're going to put those examples in these boxes just for ease. And so you can ignore the slide number, which is now in the way. So let's think about a pure substance. A pure substance is made up of one component sorry about that, and cannot be further broken down. It's important to note that it's always the same. And so when you have a pure substance, it can either be one of two things. We can have an element, which is, to be quite honest, something on the periodic table. So we'll start with that. And it cannot be broken down. And so if we were to think about examples of that, that would be things like iron, which is Fe. We could have oxygen, which is O, or other compounds. So a compound is two or more elements in a fixed ratio. So that would be things like water, which is H2O, a compound we will get to know, which is CH4, methane. We could also think about NaCl, which is table salt. So a compound in this case is going to be always the same. Sodium chloride in terms of table salt is always in a 1-to-1 ratio. So an element is something from the periodic table. A compound is a specific relationship. So let's think about a mixture. So I'm going to scroll this up a little bit, and then we'll scroll it back down to look at our examples. So a mixture, two or more elements in varying ratios. And so they could be in lots of different ratios. So we could see something like a 1-to-1, a 1-to-2, a 2-to-1, depending on the elements. And so mixtures can be created in things like homogeneous or homogeneous, which means the mixture has the same composition. Or heterogeneous, the mixture varies. So, or the composition varies throughout the mixture. And so some examples of these, so a homogeneous compound might be a sugar cookie or quartz, where you can see that quartz is made up of many different compounds or different elements and it all looks different, but there's not really a way for you to separate that. Whereas a heterogeneous, so if we were to take our sugar cookie and add M&Ms to it, you could, I'm not sure why you would, but you could physically separate out the M&Ms from the sugar cookie dough. So we'll say an M&M cookie or a chocolate chip cookie or an oatmeal raisin cookie, all of those types of things. Or if you were to think about a bowl of candy, so a heterogeneous mixture means that you could separate that. So if you were to have ice in your water, you could separate the ice from the water. Whereas if you had a mixture of anything else, you might not be able to do that. So once we kind of know what mixtures are, we also want to think about the properties of different chemical compounds. So the properties of chemical compounds are going to determine how it behaves. And so we can think about using the properties in order to separate things. Solid separations are pretty easy. You can just look at that. You can basically sort those using your hands. For a liquid solid, you can use things called decanting or filtration. A solid and a gas, you could basically just remove the gas off of the solid, it will flow away. And so if you have a liquid, you can use distillation. The properties of these substances are things that we'll study throughout your career in chemistry. What is the boiling point? What is the freezing point? How does it behave? What does it do? We can use those properties to determine how it functions. And so some of the chemical behaviors we're going to want to track are things like physical changes. So the state changes. So we know that water can be a solid, liquid, or a gas. And so the chemical composition does not change. So the chemical stays the same, it just changes its physical state. Some of the physical properties, these are things that are displayed without changing compositions. And so a physical property doesn't change the chemical, but a chemical change, the chemical composition is going to change. So the composition will change. We will make a new compound. So chemical changes can be where compounds are put together or where they're taken apart or just a rearrangement. And so that is a chemical change. And so the chemical property is displayed as a result of the chemical change. And so we will see lots of these throughout the semester. And so the question will be, what is a chemical change and what is a physical change? But throughout this semester or through these videos, we are going to think about how do chemicals behave.